Hello, this is Bob Swanson, ICC astronomy instructor, and I wanted to walk you through the Module 9 lab activity. This is about eclipsing binary stars, and I'm going to make a two-part video. The first part is going to deal with the student guide. Again, I always recommend you do the student guide. It's not something you're going to turn in, but it is something that will help you to prepare for the lab quiz. It's really the best way to learn about the simulator. You don't necessarily need to do, you will need all the information that you learn in the student guide to do the lab quiz successfully, but you may see this additional information show up on a midterm or a final, that sort of thing. So just going to step you through the student guide first in this video, and then I'll do the lab quiz kind of step through in the second video of this series. So starting off, of course, you've printed off your student guide. One thing I will say is that we're only going to do about the first 5 pages of the student guide. There's no need to do beyond the 5th page because it gets a little bit too much inside baseball. So that limits the amount you're actually going to have to page through. But starting off on page 1 of the student guide is a question about center of mass. Again, always go through the background pages. So if you click on the center of mass background page, it's going to bring you up to a page like this. And in order to answer question 1 successfully, really all you have to do is play around with this little interactive, which allows you to change two masses. We're going to pretend they're 2 stars. And we can also change not only their masses, but also their separation. And what you'll see is that that will affect where the center of mass is located between the 2 stars. And you can either keep the center of mass fixed, or you can allow it to shift around as you change the masses. You'll see that little green crosshair labeled CM, that stands for center of mass. That'll shift around. So that's going to help you with question number 1, as well as question number 2. Essentially, you're just going to fill in a table using different values for masses. The X's stand for the positions of each of the stars. So where star 1 says X0, that just means we're going to, wherever star 1 or object 1 is, we're going to pretend its position or its place on the grid is position 0. And from that, you'll be able to then place your star 2 by just changing the separation. And then you'll also be able to identify where the position is of the center of mass. That's what the X with the with the subscript CM stands for in question 2. So really, that's all you need for questions 1 and 2 is that first background page. For the third question, it's a question about luminosity, and I recommend you go to page 3 of your background pages about luminosity and go down to the bottom interactive. And what this allows you to do is you can choose, the question asks about 2 different types of stars that have different temperatures as well as sizes. And then you can kind of play around with these 2 stars. You can either make them the same size, same temperature. You can make them the same size, different temperatures, different size, different temperatures, etc., etc. But what you can also do is watch this light meter. As you move one star in front of the other, the amount of light received changes. So that's what we're eclipsing one star with the other. And that's really what this question is getting at, is what if you had a small O2 star and you eclipsed it, you covered it over with a large M4 star. And so this bottom interactive will be useful, as well as the interactive above could be useful to you as far as figuring out the luminosity of these different types of stars. And moving on to question number 4, where you actually have a little table to fill out about luminosity. That is all about this interactive here. Same page, just the top interactive. And notice you'll see these little symbols. First of all, you have this luminosity equation. It looks very complicated, but really all it's saying is that the luminosity, the true brightness of a star, depends upon essentially 2 things. The radius of the star, or essentially the size of the star, how big the star is, as well as its temperature. Both those things affect it. The rest of these things, 4 pi, and then that funny looking squiggle thing, that's a Greek letter called sigma. Again, it's just a constant. We don't really care about it. What we do care about is the variables, the fact that you can change the radius and you can change the temperature, and both those things are going to affect the luminosity or the brightness of the star. Now going down lower into the interactive where it says solar units, essentially we treat our sun as being the standard by which we measure all things. So when you see that R with the little circle and the dot in the middle, that stands for a solar radius, or a star that has the same radius as our sun. And the T with the little circle with the little dot in the middle is a solar temperature, meaning a star that has the temperature that is the same temperature as our sun, around 5800 Kelvin. And so in this case, we'll start out with this interactive with a star much like our sun, that is 1 solar radius and has the same temperature, 1 solar temperature. And notice our sun has a luminosity of 1 solar luminosity. No big surprise. What you can do in this little interactive is you can change the radius of the star. You can either change it using the slider, or you can just type it in. I believe you can type it in. Yes, I think you can change it, type it in by just clicking on there. But you can change the radius, and that changes the luminosity. Likewise, you can change the temperature, either by typing it in or using this slider, the spectral type slider. And you'll see the combined effect of changing the temperature and the radius on the overall luminosity of the star. Okay, and then finally, question 5 asks you about a grandfather clock. For this one, I suggest checking out the fourth background page about light curves. And what you're going to see is you're going to have two stars, an orange star and a white star, and you can start to animate them. And you'll see them go around, and you'll see the light curve, the brightness over time, and how that changes as one star eclipses the other. And you'll also see this little phase thing showing up down here. How much of it has, or how much through your cycle have you gone? And another way of getting a feel for it is to click this plot data point. And if you start clicking it a bunch of times, you're going to see essentially the light curve versus time showing up. But now you're doing it light curve or magnitude versus the phase. If you do it enough, you're essentially going to create the light curve again, but instead of being versus time, it's going to be versus the phase. And so try to figure out what phase 0.25 represents. What does phase 0.5 represent? What does phase 0.75 represent? And then apply that to the motion of a minute hand of a clock. And try to figure out what phase you would have if the clock was at, I think it's 2:40 in the afternoon. Okay, so again, allow this background page number 4 to lead you in that question number 5. From there, the rest of the student guide is pretty much kind of a cookbook. If you move on through the material to page 3, it tells you to get into the simulator. Whoops. So you click on the simulator, and notice there's a lot of presets. If you select these presets to example 2, that's the first thing you're asked to do on page 3, question number 6. They want you to set the system to example 2 and then change the phase to 0.03. So again, you'll see there's an area where you can choose your phase. You put in 0.03, hit enter, and then just explain what's going on here. And the rest of it is pretty much straightforward. You just follow the instructions. It'll lead you through a bunch of the examples. Again, just to give you a better feel for this eclipsing binary simulator. Good luck.